Farm and ranch enterprises. An investigation for planning an irrigated farm is not complete until the type of enterprise that the farmer plans to develop is known. The crops to be grown, the labor available, and the intensity of the operation all influence the layout. Although the irrigator may have an opinion regarding the best method and layout, it is the job of the planner to suggest alternatives that will provide a sound basis for the final decision. The irrigation plan describes major components of the irrigation system and their operation. It lists the basic soils, agronomic and engineering data as they apply to the specific irrigated unit, and spells out in detail how irrigation water management is to be achieved. Economics. The economics of irrigation must be considered during irrigation planning. The planner needs to show that the benefits will be sufficient to justify the cost of purchasing, installing, and operating the irrigation system, and that there will be a reasonable return on time, labor, and investment. The actual cost of the system and its installation must be estimated. This cost will vary greatly depending on the type of system, size and length of the distribution lines, water source, number and type of water control structures, and other significant field conditions. The cost of operation and maintenance needs to be included. This cost may be annual power costs, water assessments, repair, maintenance, insurance, or taxes. Any additional crop production costs should be estimated, and it may be wise to develop an annual sinking fund for future equipment replacement. The returns or benefits to be accrued from irrigation should be estimated. They may consist of only the difference between the value of irrigated crops and dryland crops, or they may include such intangible items as ensuring a stabilized farm income, ensuring a feed supply for a livestock operation, allowing an increase in the production of the farming operation without adding land, and increasing the value of the land. Basic design criteria. Design criteria for each irrigation method are contained in state irrigation guides and the appropriate chapters in Section 15 of NRCS's National Engineering Handbook. Irrigation methods. Level borders. The level border method of irrigation consists of surrounding a nearly level area with a low dike and quickly filling the area with the desired amount of water. A temporary pond is created until the soil absorbs the water. Both row crops and close-grown crops may be grown in level borders as long as the crop is not affected by temporary inundation or is planted on beds so that it will remain above the water level. Level borders are useful if leaching is required to remove salts from the soil. As the intake rate of the soil increases, the stream size must be increased or the length of the run shortened so that water will cover the area within the required time. Large irrigation streams usually require higher border ridges. However, they can be used if the conditions specified in the guide are met. The area within a level border must be carefully leveled. Preferably, there should be no cross slope, and the total fall within the length of the border should not exceed half the normal net water application depth. Graded borders. With the graded border method of irrigation, the field is divided into parallel rectangular strips, separated by smaller dikes called border ridges. These ridges are broad and low enough so that they can be planted and harvested with the rest of the field. The graded border method is adapted to close-grown crops. A stream of water is introduced into the upper end and it flows across the field in a sheet between the border dikes. Efficiency of irrigation application depends on selecting the proper stream size. Border strips should not have more than 0.03 meters or 0.1 foot of cross slope. Thus, on a field that has been leveled to a cross slope of 0.3%, the border should not be more than 10 meters, that is 33 feet wide, but with a cross slope of 0.2%, borders that are 15 meters, that is 50 feet wide, may be used. On steeper slopes, something like 0.7% or greater, It may be necessary to use corrugations with the borders to spread the border stream adequately. Ideally, graded borders should have a uniform slope downfield. If this is not possible, the steepest slope should not be greater than twice the flattest slope. Slope should either steadily increase or decrease in a downstream direction. Undulating slopes are inefficient. Furrows. The furrow method of irrigation is used for row crops. Furrows are developed between the rows during planting and cultivation. Graded furrows. For the most efficient use of the graded furrow method, the largest stream practical without creating an erosion hazard should be used to force the water across the field, and then the stream should be cut back to a size that will keep runoff losses to a minimum for the remainder of the irrigation. A tailwater recovery system may be needed to increase irrigation efficiency. With level furrows, the initial stream should be used until the required amount of water is applied. The water should be ponded in the furrows until it is absorbed by the soil. The maximum stream size that may be used depends on the size, shape, and slope of the graded furrows and the erodibility of the soil. In general, furrows run downslope. However, on smooth, uniform slopes, crops can be planted across the slope to reduce the gradient. Also, on this type of slope, it is sometimes desirable to have the rows parallel to a fence or other boundary running across the slope. This is satisfactory as long as the furrows are deep enough and the soil is stable enough so that irrigation water or storm runoff does not break over from one furrow to another. Contour furrows. Contour furrows may be used on moderately steep slopes when medium deep furrows can be developed. They may be installed along with terraces on land that requires terraces for protection against erosion. Contour furrows must be planted carefully. When the guidelines or terraces spread apart in the direction of flow, the lower guideline should be followed. When they come closer together, the rows are made parallel to the upper guideline. This ensures that every furrow has a grade at least equal to the grade of the guideline or terrace. Corrugations. Corrugations are identical to furrows except that they are used with close-grown crops and may be spaced in accordance with the properties of the soil instead of the requirements of the crop. Corrugations may be used with other methods to facilitate the spreading of water or to reduce crusting. They also are used between borders to irrigate a crop or to guide water to small ridges between contour ditches. When corrugations are used in this manner, the system design is based not on the specifications for corrugations, but on the specifications for the methods they facilitate.